Now let's start with the topic, that is when an electric dipole is placed in a uniform electric field. What will be the value of force and what will be the value of torque here. So at first we have to know what is uniform electric field. So what is uniform electric field? A electric field is said to be uniform when the electric field strength at a particular region of electric field is the same. That means the magnitude value of electric field in a particular region will be the same. Then the electric field is said to be a uniform electric field. Here in figure, the red parallel lines is represent the electric field which is uniform. That means here in this region at every point the magnitude value of electric field will be the same, and the direction of electric field is along which direction? That is along positive x-axis. Now an electric dipole is placed here, that is negative charge, this one is positive charge, and the separation is 2a. So an electric dipole is placed here with a separation 2a, and this dipole is making an angle theta in the direction of electric field. Now we have to calculate the force here. At first we know that when there is a electric field in a region and there a electric charge is placed there, it explains an electric force. At electric charge are two types, so electric force result will be also two types. For at first electric force for plus q charge, what will be the result for it? The electric force for plus q charge, F plus q, result will be q into E. And what is the direction of this force? The direction of this force will be along the direction of electric field. That means along the positive x-axis. Similarly, the electric force due to a minus q charge, and the result will be E minus q, that is expression is minus q into E. And what will be the direction for it? The direction for it will be opposite to the direction of electric field, as the charge is negative. So both the forces have equal magnitude and the magnitude value is QE, but one force, that is for plus Q, it is directed along the direction of electric field, and for minus Q it is directed along the negative opposite direction of electric field. Then what will be the net force? The net force result will be cancel out, and that is the net force value is 0. So here for a uniform electric field, the net force acting on a dipole is 0. Now question হচ্ছে যে what will happen and what will not happen with this net force. We know that there are two types of motion. One is translational and another one is rotational. If there is a net force, the body will move in a straight line. But if there is a couple of force, then the body rotates and it makes a circular motion. So for a linear motion, what we need? That is net force. And for rotational motion, what we need? That is the net torque, which is made by a couple of force. So as there is a no net force, we can say that there is no translational motion of this dipole. Now we have to find out the torque acting on it for rotational motion. That means what will be the value of torque here. As we know that torque is formed by couple of forces and it is calculated by the formula, that is tau equal to magnitude value of force and the perpendicular distance between two forces. So here magnitude value of force, that means Q into E. One is plus QE, another one is minus QE. So the magnitude value of force is Q into E. That is magnitude value of force is F, that means Q into E. And what is the perpendicular distance between two forces? Here one force is plus QE, another force is minus QE. So what is the perpendicular distance? Perpendicular distance is BC. BC is the perpendicular distance between two forces. Now we have to calculate what will be the value of BC. Just see the figure. From triangle ABC, we say that AC is the base, BC is the perpendicular, and AB is the hypotenuse. So sine theta, that means perpendicular BC divided by hypotenuse, that is 2a. So what is the value of BC? BC equal to 2a into sine theta. Just putting the value of BC here. So the result of torque tau will be F equal to QE and the perpendicular distance equal to 2a sine theta. Now we know that Q into 2a, which discussed in the previous class, charge into the separation between two charges, is called electric dipole, which is denoted by symbol P. So Q into 2a is represented by P, and there is E also sine theta. So the expression of torque is tau equal to PE sine theta. So in vector form, it can be written as tau, that is equal to vector product of electric dipole moment and electric field. Now question is that what will be the direction of this torque? The direction of torque tau is that in which a right-handed screw would advance when rotated from P to Q. When rotated from P to Q, in which direction the right-handed screw would advance. And in figure, it will be directed perpendicular to and points into the plane of the paper. Then we have to calculate the SI unit of torque, and we know that the expression of torque tau is equal to force into perpendicular distance. So for expression of force, the unit is Newton, and for perpendicular distance, unit is meter. So the expression SI unit of torque is Newton meter. Now we have to find out that the condition when torque is maximum and when it becomes minimum. As we know that the expression of torque tau, that is equal to PE sine theta, that means it depends upon the sine of the angle theta, and theta is the angle between P and E, that is the angle between direction of electric dipole and the direction of electric field. So it depends upon the angle between them. So first condition, here I will make one vector. I will make one vector which represent the electric field along the positive direction of x-axis, and we keep a dipole. Along this direction, which is made by red color. Okay. So in this condition, the dipole moment P and the electric field both are parallel to each other. That means here the angle between them, theta, is equal to 0 degree. So according to formula, torque tau equal to PE sine theta, as theta 0, so the expression of torque tau is equal to 0. Now question is that what is the significance when torque tau is equal to 0? What is the significance? When tau equal to 0, that means any body is not able to move. So we can say that here the expression of torque tau is 0, that is a stable condition. Now condition number 2. Condition number 2 key. Similarly, we placed an electric field along the positive direction of x-axis, and we rotate an electric dipole through an angle of 90 degree in the anti-clockwise direction. So here the dipole moment and the electric field both are perpendicular to each other. As both are perpendicular, so the angle between them is theta equal to 90 degree, and according to formula, torque tau equal to PE sine 90. Sine 90 is 1, so the expression of torque tau, that is equal to P into E, and this is the maximum value of torque. And in what condition it will happen? It happens when electric field and dipole both are perpendicular to each other. That means when the angle between them is 90 degree. And it is not a stable condition. It is not stable. Why not stable? As the torque acting on it. Okay. Now the condition 3. Further, if we rotate the electric dipole through an angle of 90 degree, then the total angle between electric field and the dipole moment is 180 degree. Just exactly opposite to each other. So what will be the result of torque? Sine 180, that means 0. So the expression of torque tau will be 0. This is also the stable condition because here no torque. Okay. Now condition number 4. Condition number 4 key. We've placed an electric field along the positive direction of x-axis. An electric dipole is rotated through an angle of 90 degree further, and it is directed in the downward direction. So what is the angle between electric field and electric dipole now? The angle is 270. Okay. Then what will be the expression of torque? The expression of torque tau will be Pe sine 270. Sine 270 is minus 1. The expression is torque tau equal to minus Pe. And this is also not a stable condition. Okay. Because here torque is present. So basically there are two conditions. One is torque tau equal to 0, one condition, and another one is torque tau equal to Pe. One is plus Pe and another one is minus Pe. Clear? So what we discuss in this class? We discuss what is the force and what is the net force of an electric dipole placed in a uniform electric field. What is the value of torque and its direction? What is the rule? And finally, we calculate some special condition for torque. That is when torque is minimum and when torque is maximum, etc. This is all about today class. Thank you.